So the stage is yours.
Thank you very much. So, hello everyone. I'm super happy that you still pulled it through until the dinner. Hopefully you're still fit after this hot weather. So yeah, my name is Stapfer. You can find me on Twitter on my Finnish Twitter handle called Ryp, which means take a sip, like a shot in Finnish. I had the honor to stay there for a few months, so I'm really glad about this handle. Anyways, before we start this talk, I want to ask you a question, and it's a very vague question. So, how confident are you in your code? So when you think about your server code, your application code, just imagine you just added a change, you merged a branch, you committed it, everything went through code review, they merged it together, they build it on CI, the compiler says everything is fine. How confident are you? Or just raise your hand if you're 90% confident that this code will run the same way as you intended to run. Not many people, right? And there's many, I know that feeling, because you never know what slips through, right? Through the code review, or maybe the compiler doesn't catch anything. Hopefully after this talk you have some more input, more inspiration on how to fight this confidential problem, you know? To feel a little bit more confident with your build system. So let's start with a little story. So my story started somewhere in 2015 when I joined a company called Runtastic, and it's now part of the Adidas group. A fantastic company. I was introduced into the newsfeed team, and I had a very specific goal or task. So I was the JavaScript specialist, how much this is worth, and I had to onboard an iOS and Android developer to the JavaScript platform. The reason for that was they wanted to refactor their newsfeed inside their running app and their fitness app, which is called Runtastic Running and Runtastic Results. And in that time, the newsfeed was just a web view, and it was just plain HTML, and the user experience was not really good. And kind of they tried to try something new. So there was this really hot technology coming out called React Native. Who doesn't know React Native? Just quite a few people. For those that don't know it, it's a way of running a React app in the native part on iOS, on Android, with native components instead of a web view. That's probably the simplest description. And we worked as a feature team, so this whole thing needed to be built as a module, which you can just drop in to your existing applications. So this was really scary. And here are some screenshots, how this looks like. Whenever you went on the newsfeed tab, it loaded a React Native app, and you could scroll through it, and it was content-driven, and it was super fantastic. Yeah, so this was what we did. And we had a lot of responsibility. React Native runs on JavaScript, and it also ships a little core module with it. So in iOS, it runs on the JavaScript core engine in a main thread. And on Android, they ship a whole JavaScript engine with the whole React Native module, or at least back then. I guess they made it better by now. And the thing is, whenever you're running JavaScript and it's causing an exception, which is not caught, the whole application crashes. And we all know, as app developers, you don't want the app to crash. This is probably the worst thing you can have. And we also don't want to make troubles to the other teams, right? So the guys or folks working on the apps, they should not have issues because of us. So it's also an organizational problem. So how did we prevent crashes? Back then there were not many options, and code analysis, linting, yeah, they were kind of limited, but there was type checking. And back then there was TypeScript, which sadly was not an option because you needed to migrate the whole code base to TypeScript. The reason why Flow exists was that Facebook couldn't partially integrate TypeScript into their code base. That's why they built the new type checker. And Of course, Flow is also a product of Facebook, like React Native. So those two tools work together really well. And I got really into it. In the beginning, I was a little bit skeptical because I thought types were really a burden sometimes, especially when you come from Java. And it was always a hassle to match all the types, and you felt really unproductive. But Flow kind of got the sweet spot. So I got really into it and also helped out with maintaining the Flow typed definitions and tried to contribute back to the community. So everything was good, right? So we had a type checker, the type checker was checking everything, the type inference was fantastic, and the app never crashed. Well, it wasn't perfect. First of all, we didn't have an ecosystem back then. You had to write all the type definitions yourself. Of course, we had a huge list of dependencies on NPM, and you were supposed to write all the wrappings, all the typings for all this. We used very extensive libraries like Ramda or Immutable.js, and Redux Saga was also very, very hard to type. I can tell because the initial type definitions on Flow typed for Redux Saga were made by me, and generators are polymorphic by definition. So you don't know what type is going to be yielded, and you cannot really make that a single type. So it was really, really hard to express the types because JavaScript is a highly dynamic environment. So it introduced a lot of type holes with any mixed object, and I think nowadays TypeScript even has more of these kind of types, like undefined or some kind of infer type, I don't know. It's getting really extensive. And it's very hard to debug the type space. So when you're using generics or when you're typing polymorphic variadic arguments, it was always hard to, what does Flow do? Does it actually check my code? Or does it just bail and say, okay, it's just any? And you never knew. You never knew when this will happen. And therefore, the type inference was never consistent, which was sadly a problem, because we like to do a lot of functional composition in our code. The definition files per se were hard to track. It was hard to verify completeness because most of the definitions were managed by the community and not by the main contributors of the libraries. It needed to reflect the JS implementation one-to-one. And by definition, JavaScript is very dynamic, so you cannot really express everything. And there were lots of bailouts, untypable scenarios, which caused a lot of problems for us. And there was also no way to automatically convert the TypeScript definitions to the Flow definitions. I know there have been a lot of projects claiming they can do that, but there are semantic differences between the type systems, so they are not compatible in all cases. So there was a separation of the communities now. Now you suddenly had to pick a religion. Are you a TypeScript veteran, or are you a Flow type heresy guy person? So it was not perfect, but it was actually better than nothing. Because suddenly we had a much easier time communicating our communicating our interfaces. Suddenly we knew what kind of props came into our React component. Suddenly we knew how the structure of our request object looks like. And it was also easier to do the code reviews, because we just saw, okay, this is of type this, and this should be this, the structure this and that. So let's go to another war story. So I had a client which was working on a product which is an infrastructure as a service. So they were automatically deploying OpenShift clusters. And they had an authentication service where you as a developer could authenticate with an SSH key, and then you could manage the deployment details of your projects. Now imagine you have an Express server with an authentication layer where you need to make sure that the user only gets the data the user is authorized to. And it shouldn't leak any unauthorized data for obvious reasons. And one of the code looked like this. So this was basically the authentication layer in the Express middleware. And you can already tell that there are many, many occasions where the code go wrong. And then you have an unexpected behavior. Now imagine you come to the project and need to change this code. How confident would you feel Like knowing if you deploy this, suddenly someone gets access to all the data of a different company, and yeah, that would probably not be good. So this kind of things is usually where I wished that type systems were a little bit more strict. The same goes for my get project SSH keys function. So I told you there were a lot of holes in the type system. Most of the time I couldn't really express the whole situation because we were using Ramda, a functional composition library, very similar to Lodash. And whenever we tried to like pipe the data through a whole transformation pipeline, the type checker could not follow up because there were too many generics involved and the type checker was just confused. So what we did was we introduced flow fix me statements, which basically opted out of the type system. So now you have type holes in the code base where the type checker can unintentionally infer the wrong types at any position in your code, depending on where you define the border with type annotations. Legacy code got a real burden. Type systems evolved while we were trying to meet deadlines. So even like the whole engine of the type checker changed. Flow had an upgrade where they decided that object types were now from there on strict object types. So they needed to match an exact shape instead of being an open object. Now you can imagine how many type errors we got in our code base, and we still had to ship stuff. So there were only two possibilities. So either you upgrade the compiler and take a week to upgrade everything, and then you're still not sure if it works, or you just skip the upgrade and just disable everything what causes problems. We got problems with huge definition files, Lodash especially, because it was a huge file and Flow got troubles managing the memory. Therefore, the process took at least 10 seconds to build the project or to type check the project, which gave me less and less confidence in the quality of my existing code. Performance decreases were introduced in future versions. At some point, I even disabled the autocompletion in my editor, which is probably not what you would like to do if you have a type checker. Luckily, TypeScript has a very good strategy of tackling these kind of problems, and I'm very happy that they managed to build a system which is at least a little bit reliable. We also had diverging coding styles. So the teams I worked with, they preferred functional paradigms. We used a lot of Ramda, we did functional application, currying, we used function composition over class inheritance, we liked immutability over imperative mutation, and if you think about it, like the JavaScript community is very big and everyone has a different opinion on how to write code. And you just install Apollo client and suddenly you have a class-based interface. And this is just something which I find unfortunate. The ECMAScript community or the ECMAScript standard is growing indefinitely. They're trying to add all the features. They try to cover all the use cases. They try to introduce a pipe operator. They try to introduce all the class-oriented features with private accesses and such, which can be good, but at the same time you lose focus. It's always good if you have a language which is less complex. So I needed something better, something which is basically a functional programming language with good interop with existing JavaScript, especially with React, a strong type systems which doesn't introduce any type holes, with fast compilation times, and a community which goes with one mindset. I mean the functional mindset. And I have a very nice quote from a very interesting book, Coders at Work, Reflections on the Craft of Programming. So, in an interview, Joshua Block, a former Java chief architect at Google, was asked, why do people get so religious about their programming languages or paradigms? And his answer was, I don't know. But when you choose a language, you're choosing more than a set of technical trade-offs. You're choosing a community. It's like choosing a bar. Yes, you want to go to the bar that serves good drinks, but that's not the most important thing. It's who hangs out there and what they talk about. So I'm glad that today I will talk a little bit more about my favorite bar, which is ReasonML. So I just start with some features and then I just drop into coding because I think it's easier to understand how a language feels like when you really see it in action with an experienced developer. So some features, first of all, it has immutable data structures by default. You don't need immutable JS. It has records, it has lists. It has variant types with a very, very expressive pattern matching system. That means I can express requests with certain states. And when I'm in a certain state of a request, I can unpack specific data, which means I can suddenly design types which reflect the loading state of a component, but in a very idiomatic way without any runtime impact because I don't need any JavaScript objects. I have easy integration in existing TypeScript and JavaScript code bases because the compiler is so unintrusive that it just says, just give me some reason files and I will compile them to JavaScript files anywhere in your project you want. I don't need to introduce huge like runtime environments. I have first-class React bindings since the whole project is maintained by Facebook or initiated by Facebook. And the original creator of Reason is actually the creator of ReactJS, Jordan Walk. It can use the OCaml platform, and it's actually underneath the OCaml platform to compile to native binaries, which none of the gradually typed languages can do. And OCaml is a language which has been here for 20 years. The type system is stable. It will not change in the future because they have a lot of industry relying on it. And they have very clever scientists also working on the compiler. So let's get into some demo. And I think it's the easiest since yesterday I had a workshop about it for hours. There's a little bit more time to show all the features. We had a little application here which is based on Next.js. So thanks Zeit and thanks Next.js, thanks Tim for making this great tool. What we did was we built a little hiking app back then, which accesses the GraphQL server on Prismic, a CMS system, and just renders them like that. But I think I just want to go into the little details. First of all, whoa. I'm using Vim, so hopefully you're not confused by my quick interaction with my editor. So first of all, we have a pages directory. And Next defines all its components, like whenever you define a file in here and this file exports a component, it will automatically mount it on a route. So the hiking route is on /hiking right here. So the only thing I did, I configured BuckleScript, the compiler of Reason, to index the pages file folder. And what we do is we create a new page, which is called demo.re. Also next to it, we will run the BuckleScript compiler in watch mode, so you can see how fast the compiler actually is. First of all, we need a component to export for Next.js, so it knows what to render. The only thing I do is I define a function make, which is just any name. I can also call, I just call it name for now. We use JSX to reflect our HTML, and then we say hello workerconf. And if I do this, I get a type error because BuckleScript, because Reason is a monomorphic language, that means you need to comply to the type of this JSX, which means I need to convert it to a React element first. You can see it here. It gets a string and returns a React element. This looks very tedious, so the only thing we will do, we will make a shorthand, which is called S, and then we just pipe the string into the S function. That's it. We just reformat it. And the compiler says it's done. Cool. The only thing I need to do is I need to do a default export. Every binding in my program is automatically exported in my JavaScript file. We will also see that in our file structure. Maybe here. So we now have the Reason file, and next to it we have a compiled file called .bs.js. So if we go to the demo page, we will now have hello worker.conf. Right, this was easy. I have one major example which I always show, which is we will create a color cube. And the color cube will get props, and the props will be expressed as labeled arguments in my function. So I will only have a size, which is of type integer. I will have a color, which is of type string for now. And the only thing I will do, first of all, I will create a function which is called toRem. It gets a size, and it will return size as a string of int size plus rem. That's the only thing it does. And the cool thing about it, if I just look at the types, it will automatically understand that toRem is now a function which gets an integer and returns a string, because the type inference is so strong to understand that the plus plus operator is only able to concatenate two strings. And the string of int function converts the integer into a string. So what we will do is we will define a style, and React brings specific modules to do inline styles. For instance, style.make. We call this function with a labeled argument called width, and we'll put the size in there. We also have a height, toRem, size, and then we have a background color, which is color. We add a unit, an empty value at the end, so the compiler knows it needs to call the function. We now have, oh, I have a type checker error, and the interesting part is, the compiler will also help me find the error. So it will tell me, hint, did you mean toRem? Because it knows a little bit about your context. Right, I did a mistake here, so I fix it. The compiler builds. You cannot even tell that the compiler built. It's like 11 milliseconds. It's insane. Right, okay, sorry. So we had the style, it compiles. I'm not even looking at I don't even look at the window because I know it works. So what we will do here now, we will introduce the color cube. And first of all, if I don't apply any props, it will tell me automatically that this cannot work because it's still missing size and color. So let's provide the size of 5. And as you can see, the GSX is a little bit different in Reason React. So we introduce a color red. We reformat it. It compiles. And hopefully, we'll have a red square. Right. So that's not fantastic. I mean, this is something Flow probably can also do. So let's do something a little bit more complicated. Let's do some refactoring. Let's say we want to limit the color to a specific interface. So we want to restrict it to red or green. And now we will just add color here as a type. I know this looks weird. Types are all lowercase in Reason. But it makes sense if you have been playing around with it long enough. And now we get a problem that color has type color, but somewhere we wanted string. So we need to convert this first. So we make a color to string function. It gets a color. I don't even care about annotating it. I will make a pattern match. The pattern match is so the switch is an expression. It will return a value. If it's red, I return a red as a string. If it's green, I would just return green. I reformat it, that's it, and then we provide it here. We can use the pipe operator to, how's it called? Called it to string. Bam, does it compile? Oh, it's not compiling because, of course, somewhere is wanted color.cube. So we need to do this as well. Red, here we go. It compiles. Yes, maybe try a different color. Yeah, here we go. No, this is not it. This is not it. So, as you can see, the whole thing looks quite like the normal React API because it is. If we would like to introduce state, what we will do is let's introduce a current color, and let's set the current color, and we can use the React module to use a state. It will receive a function which returns the first state. The initial state is our color value we provide via the props. And the cool thing about this now, first of all, the compiler will tell us if we are having unused variables. Second of all, it will automatically know that current is now of type color, which is red or green. And the setCurrent function is also a function which receives a color and returns a color and does nothing because it does a side effect. So let's make an onClick function which receives an event and will set the current value. And the current value receives a function which receives one parameter, and then we return. What do we return? We actually want to switch the color. So what we do is we do let's switch color. Gets a color, we switch on it. If it's red, it returns green. If it's green, we return red. And as I said, okay, it doesn't compile because the syntax is broken. So we do a switch color here with our current color. Reformat it, and suddenly, okay, onClick is not used. We use it here. We don't need to do this. So if I do this, and I do reformat it, it will automatically strip away this whole thing. So now, if you look at the compiler, it compiles, and if I... Did I actually... Oh, actually, yeah, true. Yeah, true. I should use the current color, of course. Doesn't save me from logic errors, though. And now we can toggle the color. Right. So how I told you that it's easily integratable in different code bases, in JavaScript and also in TypeScript. So what Reason did, the community did, we introduced GenType, which is what you can imagine as a Babel plugin, kind of. It can do the same thing. It takes the AST, the abstract syntax tree of your code, and can generate different data from it. And it can also do file system access. So what it does, if I compile this, so let's open the VS Code editor so you can see it. So when I do this, GenType will generate me a TSX file, which will map all the immutable data structure things like my variant types and also the make function which we did, which is basically the component with all the props as parameters, and you can just import it in your TSX code base and use it. It's a black box, you just use it. And the cool thing is you don't need to keep track of anything because this thing builds so fast that you just rebuild the whole code base if you're not sure if it's like synced. And that's it. I mean, this is... The thing is, if you have a strongly typed type system with no type holes, you can suddenly generate all the types for all the different type systems. So GenType supports untyped as a plain JavaScript code base, TypeScript itself, and of course flow definition files. So I was talking a little bit, so just to get a little bit more in the big picture, we are now seeing JavaScript output. We can compile to JavaScript, but we can also compile to native. And just to give you an example on what products are being built in Reason, there is a project called OniVim 2. It's a VS Code-like implementation of Vim. So it's a Vim shell. It uses NeoVim engine, I think, in the background. It uses it to communicate with the editor core and renders the whole thing in a native API with C bindings and all that jazz. It works on all platforms, and it's not using Electron. It's basically Electron replacement. And they also made it in a way, the way OCaml works, you can compile any OCaml code to JavaScript as well. So what they did is they created a playground where they transpiled the whole engine of this native rendering also to JavaScript. So you can build a calculator in this interesting native binding API. The interesting part as well is that this thing does use a component model similar to React. Another thing I wanted to mention is that the Reason community has been thinking about how can we make native development as easy as possible. Like literally easy. There is a tool called Easy, E-S-Y. That's all we do. If you run Easy, it's very similar to NPM. It will manage all our dependencies we have, even the OCaml version, which is used to compile the native code, and all the packages we need is all in this simple file. We just run Easy, it does a one huge build, and after that everything is cached. As long as the dependencies don't change, it will not rebuild the whole source tree. And what we can do is, we can also use the build system of OCaml to build the code and then to run the code. So what I'm doing here is, I'm running a natively compiled binary which accesses the graphical endpoint of my recipe server and renders all the recipe names in the database. So is it production ready? My answer would be yes. But most of the time, when you think about technology, it's always about trade-off. It's always about what is your team doing. So should you use it, try it yourself and then judge. It's never helping if you're just looking at the shell and you're like, yeah, well, it looks kind of like TypeScript, so why should I care? So maybe you want to do something more functional, a little bit more, instead of all the things we do already. And just to give you another hint, we have a conference called ReasonConf, which happens yearly in Vienna. It's the second time it happened there. The motto of this conference was, is Reason production ready? All the talks in this playlist on here, everything which is tagged with ReasonConf 2019 refers to all the talks of people using Reason in production and how they deal with it and how they like it. Also, there will be ReasonConf in the US, in Chicago. The community is growing really big. This will happen on the 10th of October, I think. And Jordan Walk, the creator of React, as I said, is going to be the main speaker, the keynote speaker there. And the last time he did a talk was actually when he released React to the public. And after that, he never was seen on stage again. So that's really exciting. Also a list of active users of this. There are some German companies there. There's also a Viennese company here called CCA. I'm really happy that they are using it and they love it so much. And yeah, I'm also board member of the Reason Association. If you're interested more in this technology, just come to me later. I'm happy to talk about it. And that's all I got. Thank you very much and have a great dinner.